Welcome back to the video lecture series for Introduction to Data Programming using Scala. In this video we're going to continue talking about aliases, and in particular we're going to talk about how aliases interact with mutability. So in the last video we left off, we had created some variables and we had a situation that looked somewhat like this. We had shown that we could make different variables like a and b, and they were aliases for a single object. Similarly, if we had two variables str and str2, when we had set str2 to equal str, what this really did was to have them both point to the same object. So they were aliases for a single object, different names for that one object. Now in the case of int and string objects, the aliasing is not all that significant, because in the case of both of these, they are immutable objects. And so that means that the object itself cannot be changed. We've talked about val and var, val meaning that you cannot change what it refers to. So a val, you cannot change the arrow. A var you can. We made b a var, so I could actually take this arrow and make it point to something else if I wanted. But the box right here is always going to have a 7 in it, because it is the object that represents 7, and the int is immutable. Similarly with strings. Anytime you do something with a string that looks like it is making a new object, so for example if I do str2 dot to uppercase, that turns out that str2 is still unaffected. This object right here has not been changed at all. What this did is it created a completely new string. It gave it the name res0, and it did not alter the original. The only type that we have learned about so far that is mutable, that we can change, is the array type that we've learned about just recently. And so if I go ahead and I create here a val, I'll call it ARR, and I'm going to make an array that has 1, 2, 3, 4, 5 in it. Okay. And in our picture over here, I'm going to reuse my ARR, and I'm going to draw this as 1, 2, 3, 4, 5. We'll talk about in a later video how this isn't exactly the ideal way to picture an array. We'll talk about what's really going on, but this is so much easier for me to show on this that it's what I'm going to do. And now I'm going to create another variable, ARR2, and I'm going to make it be the same as ARR. It will reference the same object. So val ARR2 equals ARR. So as we saw before, I am claiming that it is an alias. We have this picture that we have right here, where I have two different variables and they are different names for the same object. But in the case of an array, we can show that that is true. If I take ARR2 sub 2 and I change its value, okay, well, if I were to do this in the picture, what that says is to take ARR's second element and change it to 99. And sure enough, if we look at the value of ARR2, we have an array that now has a 99 in it. But as you can tell from the picture, if this picture is correct, ARR has also been altered. Indeed, if we look at ARR, that is what has happened. Okay. So this is where aliases become very significant. Because the object that we're referring to is mutable, if you create an alias to it, you can inadvertently change things. Okay? We might have made this change expecting that we're changing ARR2, but not realizing that we were also changing ARR. And this is where the mutability matters. If the objects are immutable, you can't change them anyway. So what if I didn't want to make an alias? What if I wanted this array, but I wanted a full copy of it? Say I want to have a variable called ARR3, and I want it so that ARR3 refers to a copy of this array. Let's see if we can grab that and draw my arrow here. I want to produce this inside of the code. How can I do that? Well, we already know that saying val ARR3 equals ARR or ARR2, either way, is not going to work. Okay. We need to have some operation that's actually going to create a completely new array. Now, obviously I could do that by actually retyping the values, that would make a new object, obviously. But if this were something large, I don't want to have to do that. Given what we know from the API and what we know how to do with arrays and lists, the easiest way for us to do this on an array is to actually use the map method. And I want to call map, and I'm going to pass it the function x becomes x. This is the identity function. Whatever you pass in is what it gives back out. So it's not much of a map. It's not really changing anything. But map produces a new array to hold the result of the mapping. So when I execute this, it says ARR3 equals 1, 2, 99, 45. Okay? But we can show that it's actually a separate object and not an alias to the original by setting one of its elements to be something else. Now, of course, ARR3 has been changed, but if we go look at ARR or ARR2, they have not. Okay. So, hopefully this has illustrated to you why aliasing matters. The fact that when you have objects that are mutable, you can change that one object through any of its aliases, and that is true even if you didn't mean to do it. Now, of course, you might say to yourself that you would never be dumb enough to do this in your program and then not realize that you had an alias. And maybe you generally won't create aliases in this way. However, what we're going to show in the next video is that when you call functions, you are creating aliases all the time. And it's challenging to avoid. So we'll come back to that, and we'll look at how aliasing matters when we are calling functions.